One step. That is all it took for these 6 people to move from a weekend adventure to a permanent tomb. Abandoned sites don't have rules. They only have consequences. We are auditing the brutal mechanics of industrial decay. This is not a game. Do not attempt to visit these locations. See how a forgotten place can hold a death sentence for decades, just waiting for you. It was a stiflingly hot afternoon in June 2012, when the silence of a forgotten industrial wasteland in the American Midwest was broken by the crunch of heavy boots on gravel. The site was a massive, decommissioned foundry, a rotting cathedral of brick and iron that had been closed for over 30 years. Looming over the shattered roofs was the facility's crown jewel, a 100-meter-tall smokestack built from reinforced concrete and capped with a rusting iron observation platform. At the base of this titan stood Michael, a 34-year-old veteran of the urban exploration community. He was not a reckless teenager looking for a place to spray graffiti. He was a serious archivist of abandonment, a man who treated ruins with the respect usually reserved for museums. He had spent weeks studying satellite maps and old blueprints of the site. His gear was professional-grade, high-traction boots, industrial gloves, and a heavy DSLR camera strapped to his chest. He was looking for the perfect photo of the sunset from the highest point in the county. Michael circled the base of the chimney, inspecting the external ladder. It was a spine of thick steel rungs driven directly into the concrete, rising straight up into the haze. To the naked eye, the metal looked weathered, coated in a layer of orange surface rust, but structurally sound. He grabbed the first rung and pulled with all his strength. It didn't budge. He kicked it, shook it, and hung his full weight on it. The steel felt as solid as the bedrock beneath him. Satisfied with his safety check, he began his ascent. What Michael did not know, and what he physically could not see, was that this chimney was a chemical time bomb. For 40 years, this stack had vented sulfur dioxide gas from the coal furnaces below. When it rained, that gas mixed with water to form sulfuric acid. This acid didn't just wash away, it soaked into the porous concrete of the chimney shaft. Deep inside the wall, where the steel anchor bolts were buried, the acid had been silently eating the metal for 3 decades. The bolts looked thick and strong on the outside, but inside the concrete, they had been dissolved down to the thickness of a pencil lead. This is the terrifying nature of hidden corrosion. The trap is invisible until the moment it springs. Michael climbed steadily, the rhythmic clank of his boots echoing against the masonry. By the time he passed the 50-meter mark, the world below had turned into a miniature grid of brown and gray. He paused to catch his breath, wiping sweat from his eyes. The air up here was cooler, and the wind began to whistle through the rungs. He checked his grip, feeling the rough texture of the iron through his gloves. Everything still felt solid. He was calm, focused, and completely unaware that he was climbing on a skeleton of dust. He reached the 80-meter point, just below the final transition to the observation platform. Here, the wind was stronger, pushing against his back. He reached up for the next section, shifting his weight to pull himself over a slight overhang in the design. This movement changed the physics of the load. Instead of pulling down, he was now pulling out, applying tension to the anchors. It was a standard maneuver, one he had done 100 times before. But this time, the math was against him. As he transferred his 80-kilogram body weight to the upper rail, the primary anchor bolt, the one eroded by decades of acid, snapped. There was no warning creak, no slow bending of metal. It happened with a sharp, loud crack, like a gunshot. This initial failure triggered an immediate and catastrophic chain reaction known to engineers as the zipper effect. The weight of the ladder section instantly transferred to the next bolt down, which was also weak. It couldn't handle the sudden shock. Snap, then the next. Snap. In less than 1 second, the top 6 meters of the heavy steel ladder peeled away from the concrete wall like a strip of tape. Michael's brain did not even have time to process the sound before his stability was gone. His hands were still gripping the steel rung, but the rung was no longer attached to the building. For a horrific fraction of a second, he hung suspended in the air, holding on to a detached piece of metal, before gravity asserted its absolute law. The fall from 80 meters is a mathematical certainty, It takes approximately 4 seconds to hit the ground. In that time, the human mind moves from confusion to the terrifying clarity of the inevitable. The wind roared in his ears as he accelerated to over 120 kilometers per hour. There was no chance to grab another ledge, no time to scream. The impact with the reinforced concrete base of the chimney was instantaneous. The sudden deceleration resulted in massive, non-survivable trauma. The coroner's report later described the cause of death as multiple blunt force injuries, a clinical term that means the body simply could not withstand the energy of the impact. It was a painless, instant end. When the police arrived hours later, the scene was silent. The only sound was the metallic creaking of the detached ladder section, swaying gently in the wind 80 meters above, a hanging steel pendulum marking the site where a solid-looking object had betrayed a man's trust. His camera lay nearby, shattered, its memory card holding the final images of a climb that ended not because of a mistake, but because nature always reclaims what humans build. On a biting cold afternoon in January, the vast interior of a derelict automotive stamping plant in Detroit sat in frozen silence. This cathedral of industry, once the beating heart of American manufacturing, was now a graveyard of steel and dust. The air inside was colder than the snow-covered streets outside, heavy with the metallic tang of old iron and the chemical smell of stagnant oil. Into this silent tomb walked Mark, a 38-year-old structural engineer and veteran urban explorer. Mark was not a reckless thrill-seeker breaking windows for fun. He was a professional who respected the dangers of decay. He wore a heavy industrial hard hat, steel-toed boots, and carried a multi-gas monitor clipped to his chest. He understood load-bearing walls. He understood electrical grids. He believed that his knowledge was his armor. He was wrong. In the center of the main assembly hall stood the King, a colossal 500-ton hydraulic forging press built in the 1970s. It was a monolith of green-painted steel, standing 2 stories tall, its hydraulic lines hanging like dead vines. Mark approached the machine with the reverence of an archaeologist. He performed his safety checks methodically. He located the main electrical panel on the wall nearby. The heavy iron lever was pulled down, locked out, and rusted shut. The massive copper power cables had been severed by scrap thieves years ago. To any rational person, and especially to an engineer like Mark, this machine was dead. It had no electricity, it had no pump, it had no heartbeat. It was just a cold statue. Confident in this diagnosis, Mark climbed onto the waist-high steel bed of the press to get a macro photograph of the upper die mechanism. He wanted to document the precision of the tooling before it was scrapped. He crouched inside the bite zone, the open space between the massive upper ram and the lower anvil. What Mark forgot, or perhaps underestimated, was a specific invisible feature of high-tonnage hydraulic systems: the accumulator. These massive presses were designed with large pressurized tanks that acted like batteries for fluid power. They stored immense hydraulic pressure to smooth out the pump cycles during operation. Even when the electricity is cut and the pump stops spinning, a healthy accumulator can hold thousands of pounds per square inch of pressure for years, trapped behind check valves that are slowly, silently corroding. The machine wasn't dead. It was holding its breath. It was a loaded gun waiting for a finger on the trigger. As Mark adjusted his tripod, shifting his weight on the slick metal surface, his heavy canvas backpack snagged on a small, grime-covered control lever protruding from the side of the housing. It wasn't a dramatic pull. It was just a slight, accidental nudge. But it was enough. Inside the machine's rusted vanes, a decayed rubber seal on the pilot valve disintegrated under the vibration. This opened the floodgate. The stored energy in the accumulator, waiting for decades, was released in a millisecond. There was no mechanical whine of a motor starting up. There was no warning light. There was only a sharp, violent hiss of escaping fluid, followed immediately by the terrifying sound of 5 tons of steel obeying the law of gravity. The upper ram, driven by both its own immense dead weight and the residual kick of the hydraulic pressure, slammed down. It did not move slowly like in a movie. It dropped with the speed and violence of a guillotine. Mark had less than half a second to react. He managed to look up, his eyes registering the blur of motion, but his neural impulses could not travel fast enough to trigger a muscular response. The human reaction time is roughly 200 milliseconds. The machine moved faster. The upper die closed the gap instantly. The result was a catastrophic compression event. The overwhelming force of the impact was absolute, resulting in a clinical, mechanical termination. There was no struggle. There was no pain. There was no time for fear. The machine simply completed the cycle it had started 40 years ago. The ram settled into its bottom position with a dull, heavy thud that echoed through the empty factory, locking into place with a finality that shook the floor. Silence returned to the hall instantly. The only evidence of the tragedy was the settling dust and the hiss of the remaining hydraulic fluid leaking onto the cold concrete. The dead machine had claimed one final component, proving that in the world of heavy industry, potential energy never truly dies. It just waits for a path to ground. Mark's camera, knocked clear by the impact, lay on the floor recording the motionless green giant. It captured a scene of stillness, a silent testament to the fact that safety is often just a fragile illusion created by our lack of understanding of what lies beneath the surface. The trap had been set decades ago, and it waited patiently for the one person smart enough to find it, but not suspicious enough to fear it. In the damp, fog-choked hills of Appalachia, April 2005 brought a heavy, suffocating silence to the Blackwood coal mine. This facility had been shuttered since the late 80s, a sprawling maze of rusted corrugated metal and crumbling brick that the forest was slowly swallowing whole. Into this desolate theater walked two childhood friends, David and Chris. They were not thieves looking for copper. They were explorers drawn to the eerie stillness of the place where their grandfathers had once toiled. David, 32, was the cautious one, a man who checked every floorboard before stepping. Chris, 28, was the mechanic, fascinated by the massive scale of industrial engineering. They made their way to the hoist house, the towering brick building that sat directly over the main vertical shaft. This room was the brain of the mine. Inside, the air was thick, smelling of stale grease, ancient coal dust, and wet concrete. Dominated the center of the room was the hoist engine, a gigantic dual-drum winding machine the size of a locomotive. It was a beast of cast iron and steel, wound with cables as thick as a man's arm. To the untrained eye, it looked like a frozen statue, a relic of the past that could never move again. The cables hung taut, disappearing through holes in the floor, descending into the pitch-black void of the mine shaft below. David moved to the edge of the room to inspect the depth indicators, keeping his distance from the open shaft. Chris climbed into the operator's elevated chair. He wanted to feel what it was like to control the descent of hundreds of men. In front of him was a waist-high iron lever, the primary drum brake. The physics of a vertical mine shaft are governed by a simple but deadly principle: balance. To make the elevator cage easier to lift, engineers attach a massive counterweight to the other end of the cable system. This weight, often a block of solid steel or concrete weighing over 5 tons, hangs in a separate dark compartment of the shaft. When the elevator car is at the bottom, the counterweight is suspended at the top, holding an immense amount of potential energy. In this abandoned mine, the main cage was resting at the bottom of the shaft, hundreds of feet down. This meant the 5-ton counterweight was hanging silently just below the floor of the machine room, held in place only by the friction of the brake band on the drum. It was an invisible sword hanging by a thread. Chris, trying to get a better view of the massive drum, stumbled on the uneven floor. He instinctively threw out his hand to catch his balance, grabbing the cold iron of the brake lever. His full body weight pulled down on it. It wasn't an intentional act, just a clumsy, split-second reaction. But it was enough. The interior of the brake housing was sealed, protected from the elements. The heavy industrial grease inside had not dried out. It had merely thickened. The lever moved. It wasn't much, just a few inches, but it was enough to disengage the brake shoes from the drum. The reaction was instantaneous and terrifying. With the friction gone, gravity asserted its dominance. The 5-ton counterweight, hidden in the darkness below, began to fall. The massive winding drum in front of them, which had been still for decades, suddenly roared to life. It spun with a violent, high-pitched scream as the cable unspooled at lethal speed. Chris recoiled in shock, but the sequence was already irreversible. The counterweight free fell for 60 meters before the cable slack ran out or it hit a debris obstruction deep in the shaft. The impact was not just a noise, it was a seismic event. The 5-ton mass slammed into the obstruction with the force of a bomb. The kinetic energy had to go somewhere. It traveled upward through the steel frame as a massive shockwave of vibration, a harmonic hammer striking the foundations of the hoist house. The building's floor was a slab of unreinforced concrete poured in the 1940s, already weakened by moisture and time. It was not designed to withstand a simulated earthquake. David was standing near the edge of the shaft opening on a section of floor that had been silently delaminating for years. When the shockwave hit, the concrete beneath his feet simply disintegrated. It didn't crack, it pulverized. In a heartbeat, the solid ground turned into a landslide of jagged debris. David had no time to even register the fall. He fell along with tons of concrete rubble into the sub-basement machinery pit, a dark tangle of gears and supports 20 feet below. The collapse was so violent that it triggered a secondary shift in the heavy machinery, causing a cascade of steel beams to slide into the pit after him. The dust cloud that rose was thick and black, choking the air. When the noise finally subsided, the silence that returned was absolute. Chris, uninjured in the operator's chair, stared at the gaping hole where his friend had stood seconds ago. The rescue crews that arrived hours later determined that David's death had been instantaneous. The cause of death was listed as being instantaneous, caused by the crushing weight of the structural collapse. The dead machine had fired one last shot. It was a brutal lesson in industrial physics. Potential energy does not expire with time. It sits in the dark, waiting for the slightest touch to turn into kinetic violence. The lever that looked like a toy was actually the trigger of a loaded weapon, and the building itself was the trap. In the freezing gloom of March 2013, the colossal skeleton of a derelict automotive foundry in Michigan stood as a silent, decaying monument to the decline of heavy industry. The main casting hall was a cavernous space stretching for acres under a roof punctuated by shattered skylights. Snow drifted down through the holes, accumulating on the oil-stained concrete floor. The air inside was stagnant and frigid, smelling intensely of wet ash, old grease, and oxidized iron. Into this twilight world walked Jason, a 40-year-old metal scrapper driven by economic desperation. Jason was not a tourist. He was a harvester of raw materials, a man who looked at a ruined building and saw only the price per pound of steel. He carried an oxyacetylene torch and a heavy sledgehammer, the tools of deconstruction. He had already stripped the copper wiring from the walls. Now he was hunting for heavy steel. His target was the pouring aisle, the specific zone where molten iron was once transported from the furnaces to the molds. Suspended from a massive overhead gantry crane, frozen in time, hung the ladle. It was a 30-ton steel bucket, lined with thick, heat-resistant brick shaped like a giant teacup. Decades ago, this vessel had carried liquid iron at 2,000 degrees. Now it was a cold, rusting hulk hanging just 3 feet above the floor. To Jason, it was just a massive payday waiting to be harvested. But he failed to understand the treacherous mechanics of the object he was approaching. A foundry ladle is a precise machine designed to tilt. To pour out molten metal, it rotates on 2 heavy trunnions, massive pivots on either side. Because the center of gravity shifts dangerously when the ladle is full or empty, the tilting mechanism is strictly controlled by a heavy-duty worm gear system. In this abandoned facility, that valuable brass gearbox had been stripped away years ago by previous scavengers. To prevent the ladle from swinging wildly or tipping over upside down, the last workers to leave the plant had secured it in the upright position using heavy-duty grade 80 alloy chains, wrapped around the trunnion arms and anchored to the gantry frame. The chains were the only brakes left. Jason didn't see a safety mechanism. He saw 50 pounds of high-quality alloy chain that he could cut loose and carry out in his backpack. It was low-hanging fruit. He approached the ladle, the torch hissing as he lit the flame. He knelt on the concrete, positioning himself directly within the shadow of the massive steel bucket. He didn't look up to analyze the balance. He didn't consider why the chains were there in the first place. He simply applied the blue-hot flame to the links. The steel glowed cherry red, then white, and finally surrendered to the heat. As the first chain parted, the ladle shifted slightly. It groaned as the weight transferred entirely to the single remaining chain on the opposite side. This sound was a warning. The geometric balance of the 30-ton vessel was now critically compromised. But Jason was focused on the second chain. He moved to the other side, positioning himself between the ladle and a solid concrete pillar. He applied the torch again. The physics of the situation were absolute and unforgiving. The ladle, without its gearbox, is naturally unstable. Its center of gravity is high, designed to help it pour. The chains were the only thing fighting the pull of gravity. As Jason severed the final link, the tension released with a violent metallic snap that echoed like a gunshot. The reaction was instantaneous. Freed from its restraints, the 30-ton ladle immediately obeyed the laws of rotational mechanics. It didn't just fall straight down, it rotated. The heavy bottom swung upward, and the massive steel lip swung down in a violent pendulum arc. The entire vessel, weighing as much as a loaded semi-truck, flipped on its trunnions. Jason was not struck by a small piece of debris. He was caught in the path of a moving wall of steel. He attempted to scramble backward, but the speed of the rotation was faster than human reaction time. The heavy steel rim of the ladle, moving with unstoppable kinetic energy, collided with him and pinned him against the concrete floor. The impact was not a survivable event. It was a massive compressive trauma. The sheer mass of the object meant that the human body offered effectively zero resistance. There was no prolonged suffering. The biological shutdown was immediate and total. The ladle settled into its new equilibrium, inverted, swinging slightly before coming to a rest. The foundry returned to silence, save for the hissing of the torch which lay on the ground, slowly burning out. When police and recovery crews arrived days later, they found a scene that looked like a trap had been sprung. The man had not been killed by malice, but by a fundamental misunderstanding of potential energy. He had removed the only thing holding back the weight of the world, and gravity had simply done what it always does. The ladle remains there to this day, an overturned monument to the fact that in the world of heavy industry, every bolt, chain, and beam is doing a job, and removing them without understanding their purpose is a fatal gamble. In the sweltering heat of August 2014, the vast concrete skyline of a defunct grain elevator complex rose above the cornfields of rural Indiana like a fortress of solitude. This facility, abandoned since the late 90s, was a vertical labyrinth of reinforced concrete tubes designed to store millions of bushels of corn and wheat. The air inside the complex was stagnant, hot, and thick with the smell of sour mash, the distinct vinegar-like odor of rotting grain fermenting in the dark. Into this hostile environment climbed Lucas, a 29-year-old urban explorer and photographer. Lucas was drawn to the head house, the topmost floor of the elevator where the distribution machinery was located. He had climbed 20 flights of rusted stairs to reach the gallery, a long, narrow corridor suspended 50 meters above the ground. The floor here was covered in a thick carpet of gray dust, a mixture of dried pigeon guano and disintegrated corn husks. It muffled his footsteps, creating an eerie silence. Lucas was careful. He stayed on the main concrete beams, avoiding the wooden sections. However, he failed to recognize a specific danger inherent to these structures. Scattered across the floor were steel maintenance hatches, circular lids that provided access to the deep storage bins below. To the eye, they looked like solid iron plates, but chemically they were treacherous. The fermentation of grain releases heat and moisture, creating a corrosive vapor that rises to the top of the silo. For decades, this acidic vapor had been eating away at the underside of the steel hatches, turning inch-thick metal into a brittle wafer of rust, held together only by the paint and dirt on top. Lucas spotted a perfect angle for a photo near the center of the walkway. He took a step backward to frame the shot. His boot landed squarely on one of these corroded hatches. There was no resistance. The metal disintegrated instantly under his weight. In a heartbeat, the solid floor vanished, and Lucas plummeted into the abyss. He fell 15 meters, roughly 4 stories, into the dark throat of bin number 4. He did not hit the concrete bottom. Instead, he landed with a bone-jarring thud onto a sloped surface of old, spoiled corn. This material had been left behind when the facility closed, and over the years, humidity had caused the top layer to form a hard, crusty bridge, while the grain underneath remained loose and granular. The impact of his body shattered this fragile crust. This triggered a terrifying phenomenon known in the agricultural industry as an entrapping avalanche. The vibration of his fall destabilized the tons of grain stuck to the steep walls of the silo above him. It began as a low rumble, then escalated into a roar as the material detached. Lucas tried to scramble to his feet, but the physics of grain are distinct from water or soil. Grain acts like a quicksand fluid. It flows when moving, but locks solid when it stops. As he struggled, he sank deeper. Then the walls of corn collapsed inward. Tons of heavy, dusty, organic material cascaded down, burying him in seconds. He was not crushed by a single impact. He was enveloped. The grain filled the space around him, packing tightly against his body. The pressure was immense. Every cubic meter of corn weighs roughly 700 kilograms. The material pressed against his chest and back, pinning his arms to his sides. This created a deadly mechanical situation known as compression asphyxia. The human respiratory system relies on the chest expanding to draw air into the lungs. In this environment, the pressure of the grain was greater than the strength of his diaphragm muscles. Lucas exhaled, pushing a small amount of air out of his lungs. Immediately, the grain shifted to fill that microscopic void, tightening the grip. When he tried to inhale again, his chest could not expand. He was encased in a suit of armor made of corn. There was no air to breathe, only the thick, clogging dust of the collapse. The panic set in, accelerating his heart rate and oxygen demand, but the physics of the trap were absolute. He was conscious but immobilized, buried under 6 meters of material in total darkness. The struggle lasted less than 2 minutes. As the oxygen levels in his blood critically dropped, consciousness faded into a gray tunnel. The heart, deprived of oxygen, eventually ceased its rhythm. The silo returned to its heavy, hot silence. The dust slowly settled over the new mound in bin number 4, concealing the tragedy completely. Lucas had become part of the structure, claimed by a hazard that farmers fear more than machinery: the silent, fluid weight of the harvest. His camera remained on the walkway above, sitting near the open hole, a silent witness to a step that crossed the line between solid ground and the void. In the crisp, cold air of an October night in 1995, a decommissioned electrical substation in rural Illinois sat like a steel skeleton under a full moon. The familiar 60-cycle hum of electricity was gone. It was replaced by an unnerving, absolute silence, broken only by the wind rattling a loose danger height voltage sign. The chain-link fence was tall, but for Frank, a 48-year-old former electrician, it was just a minor obstacle. Frank had helped build this place 20 years ago. He knew its layout, its secrets, and its weaknesses. He felt a bitter sense of ownership. Now that it was abandoned, he had come to claim what he felt was his: the thick copper bus bars that were worth a small fortune on the scrap market. He was not a common thief. He was a professional with a plan, equipped with insulated bolt cutters and heavy-duty lineman's gloves. He knew for a fact that the main grid connection had been severed months ago. He had personally seen the utility crews disconnect the high-tension lines from the towers. In his expert mind, the substation was not just off, it was dead. It was a cold metal corpse waiting to be dissected. He cut through the fence with practiced efficiency and slipped inside, his boots crunching softly on the gravel. He moved with confidence through the maze of porcelain insulators and steel frameworks, his flashlight beam cutting through the darkness. He located his prize, a series of thick, solid copper bars running beneath the primary transformer unit. They were easily accessible, and he knew they were pure, high-grade copper. The fatal flaw in Frank's logic was not his electrical knowledge, but his assumption that off meant empty. Near the transformer sat a large gray metal box, an oil-filled capacitor bank. Frank knew what it was. In a working substation, These devices act like giant electrical shock absorbers, smoothing out power fluctuations. They are essentially giant batteries designed to store a massive charge and hold it. The standard procedure for shutting down a substation requires these capacitors to be bled or safely discharged to the ground. But in the rush to close the facility, this single critical step on a forgotten checklist had been missed. The capacitor had been holding a 40,000-volt charge for over 6 months. It was a silent, invisible reservoir of lethal energy. It was a lightning bolt trapped in a jar. Frank saw the capacitor bank, but dismissed it as inert junk. He laid out his tools on the concrete pad. He pulled on his thick, insulated rubber gloves, a professional precaution that gave him a final, false sense of security. He knelt down, the cold of the concrete seeping through his jeans. He braced his left hand against the cool, grounded metal frame of the transformer housing to steady himself. With his right hand, he raised a heavy steel wrench to the nearest copper bus bar. He was about to complete a circuit that no human body is designed to handle. As the tip of his wrench made contact with the copper, the 40,000-volt charge stored in the capacitor found its path to ground. In that microsecond, Frank's body became a biological conductor. A massive electrical current surged from the bus bar, through the wrench, up his right arm, across his chest, and down his left arm into the grounded steel frame. This path, directly across the heart, is the most lethal possible, as it guarantees the current will instantly stop the heart's rhythm. The event was almost completely silent. There was no loud explosion. There was only a brief, brilliant blue-white arc of light and a sharp crackle of ozone. The current instantly scrambled the delicate electrical signals of his nervous system. His heart did not just stop beating, its rhythm was thrown into chaos, and it instantly stopped pumping blood. The massive energy transfer also caused catastrophic internal damage along the current's path. There was no time for pain. There was no time for a final thought. The termination of all biological function was instantaneous. The substation returned to its deep, cold silence. The moon continued to shine down on the skeletal steel structures. The only sign of the event was the man lying motionless on the ground, his heavy wrench now physically welded to the copper bus bar by the intense heat of the electrical arc. Frank had accounted for every known threat, every visible danger. He had been defeated not by the power grid he respected, but by the stored energy he had overlooked, a deadly charge that had been waiting patiently in the dark for someone who knew just enough to be dangerously wrong. The dust has settled, but the traps remain. If you were trapped in a silo sinking into grain, would you use your final seconds to record a goodbye for your family? Or would you fight until the end, knowing it was useless? Tell us your survival instinct below. Most people lie to themselves about this. If you appreciate the forensic truth, subscribe now and leave a like.